The algebraic rules for solving an inequality are almost the same as for solving an equation. The only difference is when you're multiplying both sides or dividing both sides by a negative number. In that case, you have to remember to switch around the inequality sign. So I'm going to take away a 3 from both sides. Adding or subtracting any number is okay. But now I want to maybe divide both sides by -1 or multiply both sides by -1. And the second I do that, the second I either multiply or divide both sides by a negative number, you must remember to switch around the inequality sign, or if you don't, what you write is just going to be plain flat out wrong. So this looks like the kinds of numbers we want. In set builder notation, that is the set of all x's such that this is true. X is less than or equal to -9. Technically, a single number could make this true. For instance, -20 for x could make this a true statement. But a single number is not going to make this true. This is the set of all numbers that make this true. So this is the first answer, and then it wants it in interval notation. In interval notation, you always have a comma. You put the smallest number on the leftmost number on the left, and the biggest, the rightmost number on the right. The smallest is -9. The smallest is not -9. The biggest is -9. And we include -9 because there's an or equal to. It goes left forever. There's lots and lots of smaller numbers than -9. It goes left forever. And whenever you use an infinity symbol in interval notation, there's always a parentheses with it, never a bracket. So problem 13, we have these two forms of the solution, set builder notation and interval notation. Let's try this problem. I'm going to get, I'm going to add 4 y's to both sides. That'll get the y's on the left-hand side. So then I'm going to take away 3 from both sides. That'll get the numbers on the right-hand side. So I have -4y is greater than or equal to 6. Now I want to divide both sides by -4, and that's okay, but the second you divide both sides by a negative or multiply both sides by a negative number, you have to remember to turn around the inequality sign or you're just plain wrong. So in set builder notation, this would be the set of all y values such that this is true. Y is less than or equal to -3/2. In interval notation, we could use the -3/2, but I kind of like it to be -1 1/2. I don't know why, I just sort of do. If you use -3/2, it would be fine. But we want everything less than or equal to it, so we'll use brackets, and it goes left forever again. And so this is the solution in interval notation. Problem 27 is asking us, for what values of x is the red graph below the blue graph? Well, the red graph is below the blue graph when x is more than 0. At x equals 0, the two graphs hit each other at the point x equals 0, y equals 3. But if you go to the right, then the f of x graph is below the g of x graph, which means its output is smaller than the output of the g of x graph. So we want to describe all numbers greater than 0. That's what we're trying to decide. And we have to do that in set builder notation and interval notation, because that's what it asks for. So we want the set of all x's such that x is bigger than 0. Or in interval notation, since we're not including 0, we want 0 and then right forever, and a forever symbol always has the parentheses. So this is set builder notation, this is interval notation, and we're done. So problem 33 in essence asks us to make it look like problem 27 and then make a graph and use the graph to solve the inequality. So I took the left-hand side, the x plus 3, and I called it f of x. I took the right-hand side, 2x minus 5, and I called it g of x. then we're interested in when this, x plus 3, is greater than this, so when f of x is greater than g of x. Now I could have graphed both of those, but I decided not to. I decided to go over and use Desmos, and on your homework, if you want to use Desmos, you can. So I put in f of x equals x plus 3 in red, just for the heck of it, and g of x equals 2x minus 5. And I'm interested in when the red is larger, the output of the red is larger than the output of the blue. In other words, when it's on top of it. Well, it looks like it's on top of it for a lot. The question is, does it ever become where the blue is on top? And so let's take this out and see kind of where the crossover point is. The crossover point is right here, and that's at x equals 8. You can see the 8 down here. So at 8, they're equal, and less than 8 is when the red is larger. So less than 8 is what we want. We want x less than 8. Let's go back here. And if we want x less than 8, how do we make that in set builder notation? Well, it's the set of all x's such that x is less than 8. How do we make it in interval notation? Well, we want less than 8. So 8 is the big number. It's on the right. It's not or equal to, so it's strictly less than. And it goes left forever. And so these are the two versions of the answer, set builder notation and interval notation.